So let's get started. So yeah, again, welcome. I'm Laura, solution engineer now at Semi Technologies, and today I want to introduce Weaviate to you, and also a bit on how you can contribute to this. So first, a little bit about Weaviate and yeah, the problems that it solves. So what is it exactly? And I will demonstrate this with some queries. So you see how it works and what it can do. I will then explain you how Weaviate actually does this. So a little bit more towards technology. And then I will show you how to get started and how you can contribute. And then in the end, we can have some questions and maybe a discussion if you're open to that. So first, a little bit about Weaviate itself. So about the AI-based semantic search engine. We identified that, or we know from sources that around 80% of the data is unstructured text. And this comes from Forbes, actually. And the problem that comes with this is that it's difficult to search through and it's difficult to classify data. So what exactly is unstructured text? I have an example here of three product reviews of this beauty product. And we see that we have some rating in number of stars. We have a date, so that's kind of structured data. But we also, like most of the data is actually text itself. And this text is difficult to search through if you are not searching by exact matching keywords. But also, there's a lot of information hidden in these texts. So words like fear and worry and that this person thinks it's absolutely amazing are all things that are hidden in this text, and you can do search and classification for this. So how is this problem solved right now? Search is, for example, already solved by enhancing the traditional search engines with machine learning capabilities or through manual effort. And classification is already solved partly by data scientists who make models and manual effort. Well, what are the problems with this? So search, which is solved partly by machine learning capabilities. What we see mostly is that there's just a machine learning wrapper around the results that traditional search engines return. And so that partly solves the problem, but it's just really difficult to scale mostly on large data sets. Then, of course, data scientists are able to make really nice classification models already, but we see that data scientists are overqualified to do like most of the work that they are actually doing, like the pre-processing of data. And of course, they want to build models instead of just pre-processing and all that stuff. And then, of course, manual effort that's really expensive and slow, and mistakes can happen if you, for example, misclassify data here. And this is where Weaviate comes in. And Weaviate is a vector search engine, which means that it has built-in machine learning models to index data. And yeah, this automatic vector representation of data enables to search through it. And this enables that you can find actually data without using exact matching keywords, but just by providing context or semantics. It has a graph-like data model. So the database itself is not a graph database, but it's built upon a graph structure. And then next, it's completely API-based. So it has a RESTful API, but more importantly, a GraphQL API, which makes the user experience pretty good because you can exactly get what you're asking for and do semantic searches with this. I'll show this later. It's completely cloud native, so you can run it anywhere. It has an open source core, which means, well, that's also why we're here for, right? So it's all run on, all the code, sorry, is on Github, and you can see everything in here. And then what we see right now, it's mostly used for automatic classification and semantic search. But we also have use cases where Weaviate is used as core infrastructure for a database. So that's also possible. So first, I will show you how this works. I have a little demo here. What you see here is what we call the Weaviate console. It's a graphical user interface, what we built to query Weaviate. And in this field, I can make queries. In this, you will see the results in JSON format. And for this demo, I use one of our 2 demo datasets, which contains news publications and articles from the US. And this contains about 3,500 articles, which is not that much, but it's enough for a demo, of course. So yeah, let's see how GraphQL works and how queries are built up, and just to see what kind of data is in there. So I always start like this, and for now I want to see what kind of data is in there. So I start with the get function and see what kind of things. And then from here, we can see what kind of classes we have defined. So in this data set, we can ask for articles, authors, categories, and publications. So let's see what kind of publications are in there. And I just want to see the name for now. So I press enter and I see different publications. So I have around 20 publications in here, like Financial Times, New Yorkers, Vogue, etc. And we could do the same with articles. So if I do articles and the title, then I see there's many articles and of all different kinds. So this is about the Super Bowl. There's 5 reasons to live in Cologne, Germany, and so on. But as you can see here, there's no magic happening here. I'm just requesting some data from a database. That is not something really special. So now I would like to show how the semantic search then actually works. And this is where the power of Weaviate is, of course, coming in. So let's get back to the publications. And if I want to do a semantic search, I can add a filter to this class publication. And we call this the explore function. So we want to explore what kind of data is in there and then see the results. And the concepts define your search term. So let's say I'm looking for publications around the concept of fashion. And I don't want to see everything returned, but I want to be sure that Weaviate is sure that the result is 75% certain that it's actually about fashion. So what I'm doing now is I'm still getting things. I'm getting publications and just their name, but only those that are 75% sure that it's around the concept of fashion. And now, and this is where it gets interesting. Now only the publication Vogue is returned. And as you can see here, it nowhere uses the concept or the word fashion. And the fact that this publication is returned, Vogue, is just because there are articles, for example, linked to this publication that are about fashion, that mention words like clothes and trends maybe. But it has built this context around the publication that it knows it's about fashion. So now if we change it to finance, for example, we see that Vogue disappears and we get back Financial Times and Economist. And of course, we could do the same with the articles. So if I change publications to articles again, ask for the title, maybe not about finance, but now about traveling, I get back all publications about traveling. So the future of travel in 2020, cruises. So here you see there's no word travel used, but Weaviate knows that cruises is related to traveling, and that's why it gets returned here. And we can make these queries even more specific. So let's say I'm not only interested in travel, but specifically in sailing or traveling by boat or on the sea. Then I can add a filter, and it's called move to filter. Move to means I'm literally moving through the space of our data. So I start with travel and I want to move to another concept. And as I said, let's move to sailing. and we can move with a certain force. Let's apply it quite strong here. And I press enter. I see that only results around sailing, or in this case, cruising. Rhine is about rivers, get returned. So that's how the semantic search works. You don't have to return only the data that has exact matching keywords, but it's just about the semantics and the concepts. So now I just entered single words, but this also works if you put a whole natural language sentence in there. So let's say traveling in Corona times. And we see that we get an article back, everything travelers need to know about the Wuhan coronavirus. So it makes a search query around these concepts. And I can quickly show you that we use a graph database or graph structure in the database. So all the articles in this demo set are linked to certain publications. So I can also ask for in which publications all the single articles appear. I can do this like this and ask for the name. So now I not only ask for the title, but also for the publication. And here I can see I have, this was the first result. So everything travelers need to know about the coronavirus, and is published in CNN. So this is where the graph structure comes in. All right. So let's get back to the slide. So how does this actually work? How can it return things that don't have the exact matching keywords? And this is because we built Weaviate in, or we represent data in a large vector space. And this is in contrast to like row column, traditional databases, and also not in a graph structure, but it's in a vector space. And a vector space, in our case, consists of 300 dimensions. And in there, words and concepts and data objects are placed using coordinates, which are called vectors. And Weaviate learns the context of data objects and words by representing them in this 300-dimensional space. And here I will use 3 dimensions for simplification, because, I mean, who can imagine 300 dimensions? So what you see here is actually an empty Weaviate. And all the pink dots that you see, that are concepts and words in the pre-trained language model, as I explained earlier. So if you use Weaviate, it now comes with a pre-trained language model, which is used to index the data that you add later. And how these dots are placed is about their meaning and their context. So if I take an example here, the coordinates are placed by means of their meaning. So that also means that the distance between different points are mean how close and how far concepts in their meaning lie from each other. And so in this example, we have like fashion and sweater. Those are really related in their meaning, but they are very far away from, for example, article and COVID-19. So as I said, this is just an empty but pre-trained language model. So there's no actual user data in there. And so let's add a data object. How does that work? And I have an example of article here. So let's say we want to add an article to our database with the name, the impact of coronavirus on travel industry, which has maybe a certain summary of more words. It has links to authors and links to a publication. What Weaviate then does on import time is it takes all these concepts and makes basically one large sentence or one large string of it. And then it does some calculations, namely it calculates how important each word is. So you can imagine that, for example, the words coronavirus and travel and industry are more important, they have more meaning than the words has and in. and it calculates distances and then comes with, in the end, one vector of 300 dimensions, or 3 in our example. And then it can be placed in the vector space. So if we just added an article about coronavirus and traveling, maybe it will place in the middle of these 3 concepts. And what then happens if you perform a search query is that the search query will also get indexed and placed in this vector space. And then concepts or data objects that will be close to your search vector will be returned first. Okay, I hope you're still with me after this demo and explanation how it works. So I will show you now how to get started with Weaviate if you want to use it yourself. I'm not showing this with a demo because we don't have all the time of the world, but I will quickly go through some documentation. So if you are, the documentation can be found at semi.technology/documentation. And then this is Weaviate. So of course you can read all about Weaviate first, but then we have pages on getting started. And on the quick start guide, it basically explains everything you can do. So I will place links in the chat later. Yes, thanks. Sorry. Okay. So let's see here. So the quick start guide, it explains you how to get started with Docker Compose, and then make a first schema, add your first data, and do some first queries. But this is all very basic. So if you want to add, for example, more of your own data, or want to have a real Weaviate running in the cloud or on your own machine, you can go to the installation page. And we basically have 4 different setups. So you can choose to use Weaviate with Docker Compose, and you can then run it locally or on the cloud. And we have a nice configuration tool also to retrieve the right configuration file for Docker Compose. And you can choose, for example, which language you want to have in there. The second option is cloud deployment. So Weaviate is also available on Google Cloud Marketplace, and you can find the details there. Then thirdly, we have Weaviate Cluster Service. And this is if you want to have Weaviate running in the cloud, but you don't have your own cloud instances available, then you can run it on our cloud services. And you can try it out 2 weeks for free. And it's all explained in the console. So you need to make an account in the console. And then you can create a cluster here. And then the sandbox of 2 weeks is for free. You can enable or disable authentication. You can even choose to have the demo data set that I just showed you already in there, and the language, and then you can create it. And it will take like 5 minutes to start up this cluster before you can use it. And then the last option is with Kubernetes, and that's really for large-scale production setups if you have really big data sets. And so this is not if you want to get started, I think, but we have all the Helm charts available if you're interested. And then since Weaviate is all on API level, let's say, we have made already 3 client libraries in Go, Python, and JavaScript. And I will just show you Python now really quickly. It's available just via pip install. And you can use it really easily in your Python scripts to do all the query operations. And they are all explained in the RESTful API documentation and GraphQL documentation. So for example, in the GraphQL documentation, this is one of the queries I just showed you. So this is a simple query. And then we also have it, you can see how this is done in Python, JavaScript, Go, or old-fashioned with curl. So yeah, that's how you basically can get started using your own language as well. And then we have different how-to guides if you want to have more details on how to get started with specific topics. And then how to contribute. So this is the main theme of this meetup, of course. So we're currently working towards a standalone version. Weaviate is now still dependent on Elasticsearch as a backend database, but in a bit more than a month, we are moving to a standalone version. So we're working hard on that. But of course, there are way more ways to contribute to the open source Weaviate. And I basically split this up into two areas. So we have, first of all, you can of course contribute on code on GitHub on one of our projects. And second is also just providing feedback or ideas or testing in words on one of our channels is of course also contributing on improving Weaviate and so on. So first, contribute in code or in GitHub. So we have various open projects, and I'll just quickly show you where to find this and how to get started. So first one is we have on GitHub on Weaviate core, we have issues with the label good first issue. So if you go to Weaviate GitHub, I will share the link later also, and go to issues, then you can filter with the label, and you see issues that are good to start with, that are like really easy and low level to start with. Currently we have one, there will be more in the future for sure. Second one is we want to have a Weaviate Java client at some point. So as I just showed you in the documentation, we currently have three client libraries in Go, Python, and JavaScript. But since Weaviate is on API level, and we have heard from our users that also they want to run Weaviate from their Java scripts, or like Java codes, then there's currently no like real client available, and we want to make this available. And like developing such a Java client can be really like rather straightforward, because they're like the three clients that we have are really good examples, and in Java it can be made with the same design and the same function structure basically. And so in our documentation we also have contributors guide on the right side, where you can also find information on how to develop such a Weaviate client. So we have certain guidelines for this, which functions it, for example, all needs to have before it can be fully used for Weaviate. So that's an option. Then we are always looking for demo datasets. So as I said, we have two demo datasets available and running actually on cloud instances right now, which you can directly use. But of course, Weaviate is a very generic solution to many, many problems and many use cases. So we're always looking for other datasets in other, for example, business use cases. And I can show an example here. So I've made a while ago a demo on arXiv scientific papers. So that's like a data set of 1.7 million scientific papers. And I made some scripts to pull the data from internet and then make a schema and then import it to Weaviate and make test queries. And how I set this up also with like continuous integration and so on is all open on GitHub as well, of course. So if you want to use Weaviate for your own projects, for your own data set, you can look at this example on how to get started with this. And of course, we are always open to collaborate with forming new data sets and running it on cloud instances for testing and so on. Then fourth is software testing. So of course, since it's a software project, we do a lot of testing. And this becomes even more important now that our like core Weaviate, but also all the other GitHub repositories are growing, but also our user base is growing. It's super important. And then like, besides the usual like functional testing, like unit testing and integration testing, we also want to do usability testing or scalability testing, for example. And these are all cases that we do ourselves, of course, as well. But if you want to test it on your own data set or with yourself as user, with other users, that's of course super great and super important to improve Weaviate. And then lastly, we have quite extensive documentation. And as most of you are new to Weaviate, you will probably use the documentation a lot to get started and to use specific API functions and so on. And any kind of feedback on this is really important for us and for Weaviate, because of course how the users start using it determines on how Weaviate will actually be used in their projects later. So any kind of feedback is welcome, not only things that can be improved, but maybe also things that you find really helpful. So we can improve that. And then, yeah, as I just showed you quickly already, we have a contributors guide on the documentation. So it's over here. And in the contributors guide, you can find all information on how we develop software and what the philosophy is behind Weaviate and behind developing for Weaviate. And also how to build, run and test the code, for example. And as you can see here, how to set up your local environment to get started developing for Weaviate. And then, as I said, some guidelines on making a client. But also we have benchmarks on some tests that we do on the language model. It can all be found here. All right, then secondly, you can contribute to improving Weaviate by just giving feedback in one of our channels. So yeah, as I said, please just try out Weaviate, see what you can do with it, and then you can bring your own use case on open or closed data. Of course, if it's open data, that's super great, because that means you can also share it with other community members. And also on one of our channels. But of course, you can use Weaviate for closed data as well. Yeah, as I said, all ideas are welcome. So you can think of also new features or features that you think are missing, and post a question on as an issue on GitHub or on Stack Overflow or on Slack or on one of our other social media channels, because we read them all and we have active community members on them all. So that's great. Yeah, so that's what I wanted to share you about Weaviate and how to contribute today.